Hello, everybody. Here we are, 5.1 applied problems. So this is kind of continuing on with 5.1. We've done some of the kind of theoretical stuff, and I think we did it. We did a couple of questions with this class, at least kind of as a preview. So let's start with some notes. Can you write down? So basically, we're learning about multiplying polynomials. Remember what the questions have looked like that we've done. So remember what we're learning. You're multiplying polynomials, and typically we have some unknown like x and a length that is more a number or less a number. So typically up until this point we've had something that looks like x plus 4 multiplied by like 2x, subtract 3. And so when we go through these word problems, we're going to kind of like try to get to a place where we have something that looks like this that we can solve. So good, like, to understand the problem, and good to think like, where are we likely to be headed just based on what we're learning. So let's read the question. We can read it again, draw a picture like I like to, and hopefully that helps us out. So the width of a deck that surrounds a square wading pool is I said that's so weird. The width of a deck that surrounds a square wading pool is 2 meters. Wow. Okay, so we got a square wading pool. And the width of the deck that surrounds it is 2 meters. Okay, so that's 2 meters, that's 2 meters, that's 2 meters, that's 2 meters. And here's our little pool right there. Pool, pool, pool. Beautiful. Okay, write a polynomial expression that represents the area of the pool and the deck. Okay, so we want the area. Remember, this is length times width. So we're going to get this section right here, this whole side, times this whole side here. So what is that? We remember we're kind of after something that looks like this. So we have an unknown area, the x. Okay, that's the wading pool. That's our question mark. We don't know how long that is. And we have a section right here that's 2 meters. And we have a section right here that's 2 meters. I think that's a difficult part about this question. You might be tempted to do x plus 2. But you have plus 2 meters on one side of the pool and plus 2 meters on the other side of the pool. So x plus 4. And this way, we also have an x, the unknown side. It's a square. And we have 2 meters of deck there. And we have 2 meters of deck there. So that's also x plus 4. And now we can FOIL or multiply inside like we're used to. So let's do our first and outside. And then let's do our inside and last. So x times x is an x squared. X times 4 is plus 4x. 4 times x is plus 4x. And 4 times 4 is 16. And then we're going to combine our like terms. And we get x squared plus 8x plus 16. So that's an expression for the area, the length times the width of this pool, with some unknown size. We don't know the dimensions of the pool. We know the deck, but we don't know the pool. That's our x. So what is the area of the deck and the pool if the pool has an area of 49 meters squared? Okay, so if the area, remember our relationship between the area and the side length, that the square root of the area equals the side length. So the square root of 49 is going to equal the side length of the pool. And now we can put this 7 into our equation at either point. We could do this beginning part. So we could have 7 plus 4 times 7 plus 4. So we found out our x, and we're replacing our 7 with the x. And that is 11 times 11 equals 121. That's meters squared. Or we could put it into this version of the equation. So 7 squared plus 8 times 7. I'm just substituting our 7 in for our x's, plus 16. That's 49 plus 56 plus 16. And you can add all those up, but I'm going to tell you it's 121 meters squared. So you could add it at either point. And this is also like a way if you want to check your answers. If you do this, you FOIL it and you get this answer, you could also substitute some value in for x here and just make sure you get the same answer. And that's a way of checking your answer if you'd like. It'd be good on a test just to make sure you've done something right. You can totally do that. Okay, number 2. A mirror mounted horizontally on a wall has a width to height ratio of 5:2. So we got a mirror mounted horizontally. We got a width to height ratio of 5:2. And it says the mirror frame adds 6 inches to the width and 4 inches to the height. Okay, and this is an important wording. This is like where your reading comprehension is really important. So this is slightly different than our pool, where it says that there's 2 meters all around. It's saying the mirror frame adds 6 inches to the width. So 6 inches total, which means this plus this is 6 inches, which means that each side we could presume, if it's an even frame, is 3 inches and 3 inches. And it adds 4 inches to the height. So this plus this is 4 inches. Okay, so a little bit different. They didn't say that it's 4 inches all around. They said that it adds that much to the length. So we can presume this is, 2 inches and 2 inches and 3 inches and 3 inches. Okay. And in the middle, we don't know the length, but we know that whatever it is, the ratio is 5:2. So it's going to be 2x and 5x. Because no matter what it is, if it's 1 meter, this would be 5. If we put in a 1 into this x, that would be 5 and that would be 2. If, say, the length or inches, say that it's, 20 inches, that would be 100 and that would be 40. We'd still have a 5:2 ratio. So that's why they give us that piece of information and how it affects our x. So I think that's all I need to do. A mirror mounted horizontally on the wall has a width to height ratio of 5:2. We've got that. The mirror frame adds 6 inches to the width and 4 inches to the height. Okay, so really I recommend drawing a picture to understand what's going on. And really pay attention closely to the words. So write a polynomial expression that represents the total area of the mirror. So area, remember, length times width, including the frame, and multiply to combine like terms. So here we go. We have on one side our 5x, our width, plus the 6 inches. And on our height, we have the 2x and plus the 4 inches. And then we need to multiply and combine like terms. So let's do our first and our outside. And then let's do our inside terms and our last terms. So 5x times 2x, you multiply the numbers in front. So 5 times 2 is 10, and x times x is x squared. Next, we have 5x plus 4, so 5 times 4 is 20, and we just bring our x along. Next, our inside terms, 6 times 2 plus 12 x. And our last term, 6 times 4 is plus 24. And now we're going to combine those like terms right there. So we end up with 10x squared. 20 plus 12 is 32x. And we got the 24, no other like terms. And then here we go, calculate the total area when x equals 8 inches. So we can either, and I'll show you both, substitute the 8 into x in this version or in this one over here. So we could go 5 times 8 plus 6 times 2 times 8 plus 4. So that's 40 plus 6, 46 times 20. So 2 times 8 is 16 plus 4 is 20. And let's see, I don't know that. 46 times 20 equals 920. And that's inches, let's not forget, squared, because it's asking for the area. And now let's do this one. We can substitute 8 into x. 10 times 8 squared plus 32 times 8 plus 24. Okay, so here we have 8 squared, you'll recall, is 8 times 8 is 64. 64 times 10 is 640 plus 32 times 8, 256 plus 24. And let me just confirm, plus 640 plus, what was their last one? 24 equals 920. Ooh. 920 inches squared. So you can use either version to solve that. And as I said again, you can use this method, to confirm if you have a right answer or not. I think we just got one. Write the expression to calculate the area of the larger rectangle. So they mean the entire larger rectangle, because on number or letter C, we're going to get to just the shaded part. So they're talking about the whole rectangle right here. So this length multiplied by this length. So write the expression to calculate the area. They just want the expression, but I think we should solve it. So 5x subtract 2 times 2x plus 1. And I think we should take this step to FOIL it. Let's do our first ones and our outside ones. And let's do our inside and our last. So we have 5x times 2x. 5 times 2 is 10. X times x is x squared. 5x times 1 is positive 5x. Negative 2 times 2x is minus 4x. And negative 2 times positive 1 is negative 2. And then we can combine our like terms there and there. So 10x squared, 5x plus negative 4x is just a positive x, and then subtract 2. For B, write the expression to determine the area of the smaller rectangle. So our inner rectangle right there looks like we have an x plus 3 times an x subtract 1. And again, let's FOIL, or you could do maybe let's do the box for this one. Why not? So we can have an x plus 3 and an x subtract 1. We do our x times x in this box, x squared. X times positive 3 in this box, 3x. X times negative 1 in this box, negative 1x. And negative 1 times positive 3, negative 3 in that one. And then we can combine our like terms. So we've got an x squared plus 2x subtract 3. So that's our second one right there. That one, we got that one. And now write the expression for the area of the shaded region, then simplify. So we have this whole square. We need to take away this inner square. So what are we doing here? We need to subtract a polynomial. You did do this last year in grade 9. So let's do our big one, 10x squared plus x subtract 2 minus, minus x squared plus 2x subtract 3. And when we subtract an entire polynomial like this, what it does, or what you can do to it, is change this into a plus and switch the symbol, or switch the positive or negative to all of these polynomials in this one. So this becomes now a negative x squared, this becomes a negative 2x, and this becomes a plus 3. And now we combine the like terms. So we're going to combine this 10x squared, this negative x squared. We're going to combine our x and our negative 2x. And we're going to combine our negative 2 and our positive 3. So let's do it. 10x squared plus 1 negative x, or take away